Good morning, my dear students. As you know, we have already started the settlement of shallow foundations. In this topic, we have already completed what is settlement, what are the various types of settlement, how we can calculate the immediate or initial or elastic settlement using de Beer and Martin formula, using Stein influence formula. We have also talked about how the immediate settlement can be calculated for the cohesive soil. So in today's lectures, we shall talk about how we can calculate the consolidation settlement or primary completions, or simply also we can say settlement. You can see in cohesive soil, this formula already we have talked in the 5th semesters in chapter consolidation. Sc is equal to Cc HOY 1 plus U log sigma bar plus delta sigma bar divided by delta sigma bar. So what is the, so this can also be calculated by this formula. Sc is equal to Mv. This formula also we have seen in the 5th semester. This is the another formula is also there. This formula is also utilized to solve the numericals. So what is the value? What do you mean by sigma bar? Initial effective stress, then delta sigma bar change in effective stress, Sc settlement, thickness of the layer HO, U is the initial void ratio, delta is change in void ratio, Mv is equal to coefficient of volume compressibility. In addition to that, we have also discussed about this formula in consolidation chapter, right? At the time of studying in 5th semester, Tv is equal to Cv into T by d square. Tv is the time factor, Cv is the coefficient of consolidation, T is the time, D is the drainage path. As you know that D is the drainage path is nothing but thickness of the sample divided by number of drainage faces. So this also we have talked in 5th semesters, how we can calculate the D. You see here it is written there, when U is less than 60%, U is the degree of consolidation, then we can use the formula Tv is equal to pi by 4 U divided by 100 whole square. When U is greater than 60%, in that case we can calculate the Tv by this formula. Tv can also be calculated by this formula. So what benefit is here? By this formula we can calculate the consolidation settlement in cohesive soil. Suppose you want to calculate the consolidation settlement in cohesionless soil. Here I would like to tell you, we can use the same formula which we have discussed for the immediate settlement or elastic settlement or initial settlement. That means what? De Beer and Martin formula, Simerton and Hartmann formulas. The same formula can also be utilized to calculate the consolidation settlement in cohesionless soil. In addition to that, we can also use this chart. IS code has given this. This is called a standard penetration test chart, or this chart has been given by IS code. That means what? Suppose you know the width of the footing, right? And the SPT values. SPT value means what? N values. So by using this chart, you can calculate the settlement. You can see on the y-axis, settlement per unit pressure in kilonewton per meter square is given. Width of the footing is also given on the x-axis. So if you know the values of width of the footing and the number of blows or SPT values, you can calculate the settlement. See, settlement can also be, consolidation settlement can also be calculated using the plate load test. Plate load test also we have discussed in 5th semesters. So using the plate load test, we can find out the settlement as well as the bearing capacity of soil also we can find out by this test, plate load test. So next one is the causes of settlement of foundation. As we have discussed, the load, definitely the load causes the settlement. Load means what? Foundation load, the structure load causes the settlement. In addition to that, some other parameters are also there, which also causes the settlement. For example, underground erosion. Suppose below the foundations, if there is a chance of erosions, right? So what will happen? The underground erosions will cause the settlement. Next is the structure collapse of soil. You have constructed the structure. You do not know what are the materials available below the base of the footing. Suppose the materials are available below the base of the footing: gypsum, silt, saline, right? These materials can be dissolved in the rainy seasons. So if these materials are going to dissolve and which is available below the base of the footing, there is a chance of settlement. Thermal changes. See, expansive nature of the soil. As you know, the black cotton soil expand and swell also. Expand means swelling and shrink also. So this can also cause the settlement of the frost heave. From the ground surface up to the some depth in cold regions, the soil also becomes ice, right? So if you are not going to find out up to what depth the these frosts are going to generate, or the ice is going to be formed, right? Then what will happen? There is a chance of settlement. That means we have to construct the foundation below the frost heave. The next point is vibration and shocks. When the structures are available below the beside the mining area, for example, mining area. So in that case, you know, in the mining or the excavation of coal or the minerals, the mining officials carries out blastings. This blasting also generates the vibrations and shocks, which may cause the settlement of the structure or the cracks in the settlements, cracks in the structure. Mining subsidence. You can see in the mining area, underground mines is also there. So on the ground surface, a structure has been constructed, and below that mining is carried out. If there is no proper support for the control of mine subsidence, the structure may settle down. Landslides. In some regions, the structure are constructed on the inclined surface. If proper protection is not there, in that case, the settlement will take place due to the landslides. Creep can also, it is a long phenomena, right? It is a long phenomena. It comes under the secondary consolidation, secondary settlements. It takes lots of time. It's a time-dependent phenomenon. This can also cause the settlements. Changing the vicinity, that means what? Suppose you have constructed your structure at the depth of the foundation of your structure is up to 3 meters, and adjacent to that, your neighbor is also going to construct the structure. A structure means what? The foundation of the structure is he is going to construct up to 4 meter or 5 meter depth. In that case, your foundation may become unstable, and there is a chance of settlements. Next point is how we can go for the remedial measures, how we can control the settlements. See, settlement is a natural phenomenon. It is definitely unavoidable circumstances, but some measures we can take for the control of settlement. Removal of soft soil strata. That means what? Wherever you are going to construct the structure, you can remove the soft soil and then you can start the construction. Use of oil foundation can also control the settlements. The third point is that if you are going to construct the structure on cohesive soil, in that case, how we can avoid the lateral expansion of the soil mass? For this, we can give some times so that from the side of the structure, the poor water pressure will be released, or poor water pressure will be expelled. In that case, what will happen? The structure will come on the solid particles. How we can explain in proper way? Suppose soil is saturated, you have constructed a structure. You are going to start the constructing the structure. So in that case, you have to allow the poor water pressure to release so that the structure will come to the only solid particles. So this will also control the settlements. Next is we have to construct the shape and size of the foundation in such a way so that informed settlement will be there. Informed settlement is not harmful compared to differential settlement. And pre-consolidation of building site. Pre-consolidation means we have to compact the site, we have to go for the soil stabilization before construction of the structure. So this is all about your this topic. So settlement of foundation is completed today. That means both the parts. The first part of the settlement of the first part is the bearing capacity of shallow foundation already have completed, and today we are going to complete the settlement of shallow foundation. So in the next lecture, that means tomorrow, we shall go for the unit 3.